Let's talk about polar coordinates in 2 dimensions. So we're very familiar with a coordinate system where we have x and y coordinates, and that's useful when we have rectangular systems. But sometimes you have systems that look like a circle, have circular symmetry in the plane, and for those it's best to instead use the coordinates r and theta, which are defined as follows. So we define some origin, and then we have a distance r from the origin to some point, and we define an axis from which we have an angle theta from which we can rotate round. Of course, r can be between 0 and infinity. We can go out to any distance, and the angle theta can be anywhere between 0 and 2 pi. Now, we've been doing integration in order to sum up area elements, and we saw that the little area element dA in x and y coordinates is given by delta x, delta y. So what is the equivalent in r and theta coordinates? Well, what we want to do again is to make a little square by changing our coordinates, and then we can calculate the area of that infinitesimally small square. So the first thing we do to calculate the area element is, we're at r and theta, the first thing we can do is we can change r by amount delta r, and that gives us a little length delta r. The other thing we can do is to change this angle theta so that this guy is now out over here, and here's delta theta. Now that makes a little arc of a circle, and the length of an arc is given by the radius r times the change in the angle. So for example, if you wanted to change the angle by 2 pi, you get 2 pi r, and of course the length of the arc is the whole of a circle, so that works correctly. Okay, so now we've drawn two sides of something which is sort of like a square. If we make these sides very short, then to first approximation it is a square, and it has sides delta r and r delta theta. So the little area element dA in two-dimensional polar coordinates is given by r dr d theta.